All right, welcome back. We're implementing a linked list architecture of an abstract list so that we can compare its performance to an array list. In this video, what we would like to do is implement the iterator of our linked list. All right, so let's go over, and remember the iterator is the object that's going to walk down our list for us. So let's go back to our code. Here we are in Eclipse. And what I'm going to do is, just like we have this private node class, I'm going to go ahead and add a private iterator class to this as well. Go ahead and explicitly make this private, and then we'll shrink it up so it doesn't take up a lot of space. Then afterwards, we'll go ahead and add a private class linked list iterator, which is going to implement the interface list iterator, which we previously created. All right, and we'll go ahead and use the right word. We'll call it implements. We're going to get an error here because linked list iterator isn't actually implementing the things that list iterator says it needs to implement. So I'll use command 1, and I'll say add the unimplemented methods, and it'll go ahead and stub out each one of the methods that we need to have in order to properly implement list iterator. Now, of course, they all have to-dos associated with them because the code isn't correct. But we'll go ahead and add things in here. All right, this is going to be, since we have a doubly linked list, what we want to do for our iterators, we're going to keep track of some instance variables in our iterator that's going to help us keep track of where we are in the list. And they're going to be pointers to nodes, a pointer to the node that's coming before our current position, and a pointer to the node that's coming after our current position. And then finally, we're going to keep track, as instance variables, we're going to keep track of whether or not we have called next recently, so that the various methods that require us to pass over a next item before we do something like remove, we can properly keep track of that. So those are our instance variables for our private class linked list iterator. Typically, for the constructor, we want to initialize those. And so when we create an iterator, we're going to use a constructor, and we'll go ahead and set our previous element to null because we're at the beginning of our list, and our post element will be the first element of the linked list that we're currently working with. Now notice that this first element is part of our parents class's instance variables. It's one of the instance variables of the parent class. Because this class is embedded within the linked list class, it has access to all the instance variables of its parent class. So we can easily initialize this linked list to point to the first element. Initially is after next will be equal to false. Has next then becomes a very easy question. It simply asks whether or not post is null. If post is not null, then we must have an element that we can walk over next time we call next. And so we can simply replace has next with a test that says return whether or not post is not equal to null. If post is not equal to null, then we have a next element that we can walk over. Similarly, next is pretty straightforward. We just need to update our pre and post links, assuming that there's an element present, and then return the element that we walk over. So our iterator for our next element will look like this. We will start by asking if there's a next element. If we don't have a next element, then we're going to throw a no such element exception, because if we were to call next, we wouldn't know what we're doing in that case. It's sort of an undefined situation. However, if we do have two elements, a pre-position and a post element, our pre element gets updated to our post element. So this is like walking down our list. Our post element gets the next element of whatever post was pointing to, is after next is true, and we're going to return whatever the pre-element's data is. So what does this look like if we go over to our drawing? What this means is it means that when we create an iterator, we start with this other, let's go ahead and do something we draw with. We create this other class called an iterator. Let's put an I there for now. It has something that's pre, which initially starts pointing to null, and it has something that's post, which initially points to the first element. When we call next, we update these pointers and we say, okay, well, whatever pre was pointing to, it doesn't matter now. Now we say pre is equal to what post is pointing to. And we say post is going to point to whatever post.next points to. So we're going to follow this arc right here and say now post points to here. We'll erase our previous link here, giving us a point that our iterator has now updated over so that this is our previous element and this is our next element. When we want to return the data, we say, okay, let's return pre and then the data here, because that's what we just walked over. If we call next again, we'll do the same thing. We'll say pre is assigned whatever post is pointing to, and we'll say post is assigned whatever post was pointing to and follow its next arc. So this will get updated to point here. As we do that, our old settings will be naturally removed. And in that way, if the iterator isn't moving, at least the pointers are walking down the end of the list. Eventually, if we keep doing that, our post pointer is going to walk off the end of the list and point also to null. At which point, when we ask if something has a next, we'll return false. It doesn't have a next anymore. So we'll update those elements along the way. So we go ahead and do that in our code by simply saying whatever pre gets whatever was post gets whatever was post's next, whatever post was pointing to, whatever the next element was. We say is after next was true, and we say get data. All right, well now, if we want to add something or we want to remove something, we have to do a little bit of splicing. And so that's just a matter of keeping track of where all of our pointers are currently located. So for adding, the first thing we want to do is we want to say, okay, well, if our previous element was null, we either have an empty list or we have a first element in the list. And if that's the case, the iterator doesn't have to do any work. We can just call add first, the method on our list, our parent class list, and just add the element as appropriate and update our local pointers, in which case pre will be equal to first and post, let's see, post should be equal to, does add first? Add first isn't going to update post. So I feel like I don't have the correct thing here, but post should be equal to first.getNext. Okay, I'm a little worried about that because I maybe just caught a bug along the way. Okay, so it's an empty list. We add our first element. Post is going to, that's why, because if this is our first element, then first.getNext is null, post is already null, and we don't have to worry about it. But we should be able to leave that there, and that's fine. If we're at the last element of the list, we need a special handling here, in which case we want to just call the parent class's add last element. And then pre is going to be equal to whatever previously was pointing to, dot get next. Or that should be the equivalent of last now. We could do that, or we could do what we had before. There are multiple ways to do it. And post should be equal to null as well, because that's last.getNext. All right. That's two degenerate cases. If we are either have an empty list, or we're the first element of the list, or we're at the last element of the list. But the more general cases, we're somewhere in the middle. In which case, because we're adding an element based on our iterator, we need to create a new node that's going to have that data in it. We'll set our previous pre-pointers next equal to the new node, and our previous post pointers set previous equal to our new node, and then we'll set previous equal to our new node. What in the heck is that? Okay, so let's take a look at what that looks like. All right, so what that means is let's say that our iterator is let's say our iterator is pointed like this. And so that means that we are going to insert an element between the second and third bits in our data. All right, so the first thing that we need to do is we need to create a new node, which is going to have our data. We said when we initialize it that the previous element is going to point to the previous element of the iterator. So this is what it's pointing to. So this will point here. And our next will point to the post element. So this will point here. Great. So that puts our new node into the chain. But what we need to do is we need to break this link and this link in order to make sure that we are properly settled in. So we'll say pre.getNext equals our new node. So we'll drop that down there, causing this link to go away. And we'll say post.getPrevious is now equal to our new node as well. Linking in our link there, eliminating our link here. So that then updates the chain so that our new element is in the appropriate location in our chain. And then the last thing that we have to do is we have to say the iterator pre points to our new node, making sure that our iterator has been updated appropriately so that it is bracketing these two elements so that our next element will then be this node here. All right, so that's what this code does right here. It splices in the generic code generally. Okay, remove is kind of the same thing in reverse. We have to remove elements from our chain if we've got it. So we have some special cases we need to account for. First of all, if we haven't just walked over something, then we need to call a new illegal state exception because that's one of our rules. We have to step over something first before we can remove it. The data that we just stepped over is going to be pre.getData. So we're going to get a reference to that so that we can return it before we're done. If it turns out that we only have one element in our list, well, this is a pretty easy case. We just set pre equal to null and post equal to null, making our iterator kind of useless, and our first equal to null and our last equal to null in our linked list, meaning we just have an empty list. If we are removing the first element or we are removing the last element, because pre points to those, then we just call our parent class as removed first and our parent class as removed last and update pre and post appropriately. Finally, if we find ourselves in a situation in the middle of the list where we want to remove an element, we say whatever pre in our iterator points to, we look at what came previous to that and we set its next equal to post, eliminating the current node that we're pointing at. And whatever post points to, we set its previous equal to whatever previous is get previous points to. So what does that look like when we do our iterator? This is gonna be a little messy. Let's see if I can get it right. All right. So we have an iterator here where pre is pointing to this element and post is pointing to this element. And so what we do is we say previous.getPrevious, and we set its next element here. So we're going to set this element here. We're going to set that equal to whatever post points to. So now we'll say this is now going to point here, boop, 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 boop. And we will eliminate this link as a result. Then the next thing we say is we say post, which is this link here, whatever post points to. We're going to set its get previous, which is right here. We're going to change that to be equal to whatever previous is get previous is. So this point right here, we say this is going to point here now, eliminating this link as a result. And then finally, we're going to set the pre itself. No, that's fine. That's fine because we're only allowed to call it one time. And so next time our iterator moves forward, we'll move past the element that we just eliminated. So that the last thing that we have to do is we have to remove the fact that we have walked over something because we just removed the element that we walked over. All right, that gives us remove. Finally, set is really trivial once you understand the process of making sure that you've walked over something next. If you have walked over something next recently, then you go ahead and just set the data for the thing that you walked over equal to what you want the new data to be. Okay? So that gives us the iterator. If all goes well, we implemented that correctly. And we've got a warning. Why do we have a warning here? It's because we never use it. Fair enough. So let me collapse that. So now we have a private class node, and we have a private class linked list iterator. We have an error in linked list because we haven't implemented a couple methods. Let's go back down to the things we haven't implemented. Now that we have getIterator, it's easy enough to use the class that we already have, that we've just created, to create an iterator and return it. All right, so to get iterator, we simply say return new linked list iterator. That will use the constructor of the class that we just made, create a constructor, or call the constructor and create an iterator that points to the first element of our list and returns it. So anyone using our linked list can get a list iterator. Fine. So now let's implement size, which is a method that I accidentally deleted previously. Size just means that we have to use one of our iterators, walk down our list, and count how many things we go past. So to figure out how long our linked list is, we'll start with a count of 0. We'll create a for loop, and we'll say that our for loop is going to create an iterator called I that gets our initialized iterator for this list. While we have a next item, we're going to walk over that item, and each time we walk over an item, we're going to count it. Finally, when we've gone through all of our elements, we no longer have a next element, we'll return the number of elements that we just counted. Okay? That just uses the iterator that we've made. Then finally, for get, we do the similar thing as our size, but we're going to stop at the appropriate element and return the element that we find along the way. So what does that look like? Go ahead and put my Java doc in for my get iterator. All right. And let's see, so get, we're asking for a particular element. If that element happens to be negative, we can't do anything about that, so we'll say no such element exception. We're going to go ahead and keep track of our count using a very similar code to what we have here for size. We're going to initialize our iterator. We're going to say I equals this.getIterator. While it has a next, now notice we're not incrementing here at the end, we're leaving that blank. Instead, we grab the element that we're walking over. We ask if our current index is equal to count. Index is the number we're looking for. If this is the element we're looking for, then we're going to go ahead and return it, ending our walk through the loop. Otherwise, we're going to increment count and continue through our loop. If it ends up the case that we've gone through our entire linked list and we've run out of things that are next, and we haven't found the index that we're looking for, it means our index number was larger than the number of elements in our list, and we go ahead and automatically throw a no such element exception at the end of our loop if we haven't found the element that we're looking for. All right, so I think that's everything in our linked list. I just want to go up here, and I realize that my package name here has an extra CS30, so I'm going to find CS30s and remove them through my code. Save that out. All right, so that is an implementation of our linked list. No implementation is trusted until you write some testing code. So in our next video, we'll write some tests for our linked list so that we believe that what we've done is implemented things that are working according to our specifications. All right, thanks for your attention.